at central and inscribed angles, the basic ideas, as well as the variations and the problems that are using the main ideas and applying them. Sometimes in math we have higher level thinking where we have to use things that are implied and are not specifically told to us. So the first thing we had learned about a circle is that a piece of a circle is called an arc. So a curve can be finished as a circle, and a piece of that curve is called an arc. So the arc all the way around the circle, we had said, is 360 degrees. So when you go all the way around, you have 360. Okay, that teaches us a few things. If we cut it in half, we have 180. And that's why a straight line's angle is considered 180. We cut it again, we know that a 90-degree angle is formed. So we've cut this circle into 4 sections. This curve or arc is 1/4 of 360 or 90. So we're going to see that the central angle is 90 and the arc is 90, so they're the same. So if their central angle is 40, then your angle is 40. Your central angle are the angles that start in the center, and they're always the same measurement as the arc. Okay, so that's a central angle. Next, we want to look at inscribed. So an inscribed angle really could be called onscribed. It's on the circle's edge. So we could go anywhere on the edge of the circle and make an angle. The vertex is on the circle. So if I have a point here A, and a point B, and a point C, okay, angle ABC is inscribed. When we make the angle a bit longer, we can see the arc that's inside of that angle. It's cutting that arc off. So the inscribed angle, when you go from a central angle, the inscribed angle is pulled backwards twice as far. So instead of going to the radius, we go twice as far. Because in a circle, when we have a radius, when we go the opposite direction, we make a diameter, and it's going back twice as far. So when we do that, the angle ends up being double the angle, or the angle will equal half the arc. So we always want to remember that the arc will be bigger than the angle. So if this is 80 degrees, the angle will be 40 degrees. Let me erase the central angle here. Okay, and the reverse will be true. If we're given the angle, we could double it to get the arc. So if you don't have the inscribed, or the arc, if you have the angle is 50 degrees, we know that the arc that's being used is the green one, and it's going to be double. Again, the arc will be the bigger one, right? So really we see a lot of the answers we'll get is either 100 or they'll put half. So we don't always just get half. We don't always get half of everything. We have to look. The angle is half. So if you're given the angle to get the arc, okay, the arc is double. Let's show why that happens with algebra. Well, if the angle is half the arc, we could actually put this in. If we don't know the arc is x, the angle is 50 equals 1/2 of x. When we multiply both sides by 2 to get x alone, 2 times 50 is 100, so x will be 100. So let's look at some variations of central and inscribed angles and analyze what's implied or what they're not telling you that you need to know, and you need to use that information to do a few steps to get to an answer. So one variation might be like this. And they want x. They would give you maybe this side 110 degrees. So this blue arc is 110. And the arc that goes with angle x, the central angle, would be the green one, the green colored arc. Okay, arc AB. Okay, what we want to notice is that the half circle is right there. Arc ABC, we use 3 letters for half or more. Okay, it's a semicircle or half a circle, right? All of this amount is half. And they're hoping that you see that you have a diameter. The diameter cuts the circle in half, so we know it's half a circle, that's 180. So if this is x, then the arc is the same. So the arc plus the other arc will make a half circle, 180. We subtract on both sides, and we get x is 70. So as we do these, or when you review, you might want to pause it, see if you can get the right answer, and then you can see the explanation. But again, this question didn't tell you that there's 180. This number was not there. It implies it by showing you the diameter, and that's how you know it's half a circle. Okay, we have another variation sometimes that's used. And maybe it looks something like this. So from A to C, the arc is 150. And from C to B, let's make it 120. So this is what the problem would start like if you wanted to pause it and see if you can get the right answer. So arc AC, I'm going to color in blue. It's this amount here. Arc CB, I'll color with red. It's the arc here from C to B. So what we're looking for is the one that's left over. I'll make it green, arc AB. So again, if this central angle is x, we know that this arc is x. So arc AB is the same as the central angle. Okay, so then they don't tell you, now here they're implying it's a whole circle. And the whole circle equals 360, we know, all the way around the degrees. So when you look at the 3 colors, they're actually giving you the whole circumference around the circle. So we know that those 3 add up to 360. And you'll subtract them from 360. So we can actually add those together first. Some of you prefer it that way. And subtract both sides. And the answer is 90. Now it doesn't look 90, but it's not to scale. I made the problem up. The central angle would be 90 and the arc is 90. Okay, so here's a variation where we have the whole circle. Okay, sometimes there's 2 more things that you might see. Or actually more variations than that, but here's a couple more common ones. Sometimes they'll give you 2 things together. Okay, so we're going to use a central angle and an inscribed angle. But we're going to notice, hopefully, that they're using the same arc, AB. And we're trying to find x and we're trying to find y. So let me finish this problem. And this is what it might look like. So to begin this problem, since we know the central angle is x, we know this arc is the same, so we could put an x there for that arc. So again, what we have is from A to B, where x is blue. From C to B is green. And from A to C here is red. So again, we're using the whole circle. So we know that the x plus the 130 plus the 150 surround the circle, and the circumference is always 360, or the degree measurement. So we have x plus 280, and when we subtract it, we get 80. So that gives us the angle and the arc of x. The central angle is 80 and the arc that goes with it is 80. So now because we have angle y using the same arc, angle y is inscribed. Okay, whereas x was the central angle. So it's going to be half the arc. So we had to find that arc in order to do angle y. And now that we found it, we know it's half of 80 or 40 degrees. So let me add one more thing here. Sometimes you'll have another central angle or another inscribed angle. And the inscribed angle is also cutting off arc AB. If I make the green longer, we can see arc AB is in the mouth of that angle. So if I call that Z, then we know angle Z is going to be the same because it's going to be half the arc, half of 80. So what we'll notice is when we have central angles, even if I made another one, if they're touching the same arc, they're going to be the same because they're going to all be half of 80, half of the arc that's being used. So if you see something like this with multiple angles, but they're touching the same arc, we know all of these angles are the same. They're half of that arc. Okay, that's a variation where you see many inscribed together, or an inscribed and a central together. Okay, the last type is interesting. It's a quadrilateral which is a four-sided shape inside of a circle. So let me move that back up. And we have a quadrilateral, so they are going to use one color, but I'm going to eventually color these so we can see what's going on here. So in some ways, it's like a puzzle. You're trying to figure out what you know and what you can use to find the answer. Kind of like life. And we want this to touch here. So here you have an A, here you have a B, here you have a C. And we're not going to give you any numbers around the circle. But again, we know that all the way around the circle is 360. And maybe we put x plus 5 here. Maybe we put x minus 5 here. So what we have are two inscribed angles that are across from each other. So when we look at the one on top, I'm going to color it green. Okay, and I'm going to cut it off a little bit longer to see the arc that goes with it. So the arc in the mouth of that angle, angle x plus 5, is green. If I color in the angle below in blue and extend it, okay, I can see that the arc that goes with it here is in blue. And so again, we're seeing that the entire circle is being colored. The top angle is using the bottom arc, the bottom angle is using the top arc. Together, they're using the whole circle. So we know they're going to equal 360. Okay. However, we're not going to set them equal to 360 because inscribed angles, we want to remember, are half the arc. So if all the way around our arc gives us 360, then we need half of that. So that's why we're going to see this rule. I'm going to put them next to each other. Plus 5 minus 5 equals 180. Angles that are across from each other like this, that are inscribed, that share the same vertices, they will always add up to 180. So if I keep doing this, 5 take away 5 is 0. And x will be, when we divide both sides by 2, x will be 90. So the angle is not 90, but x is 90. We can plug it in. The top angle would be 90 plus 5. The bottom angle would be 90 minus 5. But our answer for x is 90. So that is when you have two inscribed angles across from each other, it makes a quadrilateral or a four-sided shape. When they're in a circle, the opposite ones, like x plus y, will equal 180. Let me show you that as a formula. So this one x and this one y, they're going to be equal to half of 360 or 180. The left and right also, they join each other at the edges, and so a plus b will be 180. So we can color it and remember that. Okay, here's angle x, uses all of this. Here's angle y, uses the rest. So together they're half of 360. X plus y is 360 divided by 2, or 180. That's how we would find the ones that are in a quadrilateral in a circle, which is really two inscribed angles that face each other. And hopefully the volume works on this video. Good luck.